We want to change that to is action just pressed. We'll jump. Still on the spacebar. Have to wait until I press it again. Now, if I press it here, he won't jump because I pressed it before he hit the ground. So what we're going to do now is we're going to add button buffering. A very common way to give a good feel to your platform game. So what we're going to do is we're going to go up here and we're going to public float jump buffer play. And we want that to be how many milliseconds? We generally want it to be within the average human being's reaction time. Considering the average human being's reaction time is about 200 milliseconds. That is, if something unexpected happens, that's how long it will take for your brain to process it. 200 milliseconds is a bit... If you want to have quite a good feeling to it, you want it to be slightly less than that. If you put it to 200 milliseconds, it's noticeable. Like, you might press the button at the wrong time and still get the jump. 200 milliseconds is a decent... It's probably the maximum time I would personally set any jump buffering to. You don't want it too low. You don't want it because you're running at 60 frames per second. You don't want it to be a 2-frame window. You can think about it in frames, because that's what they would do on the old classic platformers. Is you would have 4-frame window, 6-frame window, 8-frame window, 10-frame window, something like that, to press the spacebar before you hit the ground, and it will still register your jump. So, say you are at 60 frames per second. 1/60 is your tick. It's your tick count. It's how many milliseconds a single frame will take. So we're going to convert that your frame number into a set of milliseconds. So we are running at 60 frames per second, and say we want 10 frames. We want 160 milliseconds. 10 frames less than 10 frames is less than the 200 milliseconds, which is your average human reaction time. It still gives you a good feel. Like, the 10 frames is a long window, and it's a good window. So we're going to go with that as our basic one, 160. I guess 170 really is your... But with the way the frame windows... With the way the frame windows are, we'll put 170. And we will put it up here with the jump force. So how do we actually implement this in the game? Because we've now got is grounded in here and is action press. Well, we want this to be... We now want to put in here private double jump button pressed at. So now what I want to do in here is if input.is action just pressed, how does Godot do time is the next thing. OS. Is that really what I want? Ah, there we go. Ah. It was in dot time. Get ticks millisecond. So that is the time you press the button at last in milliseconds. That's all we want to do. And now what we do is, if you're grounded and is action pressed. So think about it this way. What we're doing is you've pressed the jump button while you're in the air at some point. We're going to do a time check between what the current time.getTicks millisecond is and what the time we stored when you last pressed the button is, and you still have the button down. Because it could be that you pressed it and released it because you were like, oh, I didn't mean to jump, and you could cancel your jump. You're not committed to the jump when you press the button. So we want to make sure that we're grounded, the button is pressed, and is less than jump buffer milliseconds. That's a kind of complicated AND statement in there. And we'll just run it through. So, how do we order these is another important way of... It's an important skill you'll need to know if you're learning how to program. The order of these are important. Because if this is false, it will not execute any of these. These will not... Like, if this is false and these are all ANDs, which they are, it doesn't care. It knows that if this is false, the rest of this can be ignored. You don't need to execute it. So what you need to do in your if statements, if you want it to be efficient, is to have the easiest to calculate thing first. Then the next hardest, and then the next hardest. Or, in terms of, or if there's something that maybe is similar in complexity, you want the thing that will be false more often. So we're going to be grounded a lot. So between this and this, we want the thing that will be false more often. And false more often is generally going to be you're pressing the button or not. Both of these are actually going to be false around about the same time. But this getTicks millisecond. Don't know how quick it is to poll the ticks versus polling your input. Polling your input might actually take a few cycles. But unless we actually get down to the nitty-gritty of benchmarking this, we don't really know. But in this case, the most important thing is we're going to put the is grounded first, because you only really care about this when you're grounded. You're going to ignore it when you're in the air. And that's a really easy check because it's just a boolean. It is currently a null check. That's really quick to do. And we also want to talk about premature optimization. These two lines of code will probably not cause you any sort of crunching problems. There will be no processing problems if you flip these about. Like, you might save a couple of microseconds by flipping these two about per frame when they're false. But it's not gonna... You're not going to drop frames because of it. I'm only bringing this up now because this is the most complicated if statement that we've written, and the order of things does matter in an if statement. I kind of want to make it a teaching moment. What it means is you can do something like is grounded, and then you could go off and do a raycast in the same line. And it'll only raycast when that thing is true. That kind of thing. You can go off and do some number crunching, and if it's not, it won't try that number crunching. It's an easy optimization that you can do when you're just writing your code as is. It means you don't have to go back and think about it. It's just something you can implement into your everyday coding style. So now we've got that in. That should just be our jump buffer. So we'll go back to the game. We'll run it. And I will press it just before I hit the ground. Don't know if you can hear the clicky of the keyboard. But I will press it now. No jump. We'll press it now. You get a jump. We'll make it a bit more clearer by increasing the jump buffer milliseconds to a full second. That should be 1,000, not 100. So if I press it now, jump. Jump. Because it's going to take a second for it to hit the ground. So we'll make that half a second just so that we can see it a bit more clearly. So if I hit it now, no jump. If I hit it now, jump. If I hit it now, jump. If I hit it now, no jump. That's your bump. That's your jump buffering. Put that back down to 170 because it's a bit more of a... It's a human relatable time. And that's us. That's pretty much us got basically a platforming engine. Jump's a bit floaty, but thankfully we can change this. We can make the maximum Y speed 1,000 units. We can increase the gravity a bit more. There we go. We've got a bit more of a weighty platformer to it. Probably want to increase that walk speed, double that, just to make it a bit better feel. There we go. That does feel a bit better. Big digital controls, lots of air control. It's not Super Mario, but it is something. And that's just our main movement. I'm also going to show you what I meant by the platforms as well. I'm going to take all three. We're going to name that platform. We're going to change that to... Where is it? I never remember where these... Oh, it's in Area 2. That's where it is. Collision. We're going to move that from there to platforms. I'm going to bring it up. No, we're going to bring the platform up a bit. Change the area 2D. Make it 250. Oh, no. We've got to make unique, then make it 250, because they're all sharing the same one. But let's have that in there. Okay, so Godot has kind of got this kind of thing built in as well for one-way platform. So it is something that it has thought about, which is quite handy. So we'll make that a platform. So we should be able to land on this, walk off the edge, and then jump up through it. If my jump height was better. We'll put that down a bit lower. There we go. And you can see a little bit of pop there. But it's a bit thick. But that doesn't matter. That doesn't matter. That's perfectly fine with me. What was the next thing we could do? We could do fall through platforms. And what we'll do is we'll make this slightly thinner as well. Let's shape. Transform. There we go. Make that a little bit thinner, just to differentiate it, make sure we can see it's a platform. We'll maybe make it a little bit darker too. Okay, so we are platform. We now need to add in our down. So we're going to use our jump button for this. So if we're holding down, we want to be, maybe we want to crouch. We don't care about crouching, it's an animation thing. But we do want to be aware of the down button. So we want to branch off the jump logic from this. We do want to keep that outside though. Do we? Do we? If you're in the air and you're holding down and you press jump, then you let go of down and you're still holding jump, would that signify a jump? I think that would signify a jump. So we do want to hold that. But if you hit the ground, so here, okay, edge cases. If you're falling down and you're holding down and you hit jump, and then you release jump, hit the ground, and then hit down again. Sorry. You're falling, you're holding down, press jump, you release down, hit the ground, you're expecting a jump. That's fine. If you're holding down and press jump, and then release down, sorry. You're holding down, and you're in the air, and you're falling down, you hit jump, you hit the ground, you're not expecting a jump. But if you release down, you're still not expecting a jump. So, if is grounded, we cancel the jump buffering, so that if you release down, you're not going to suddenly leap into the air. And remember, this is going to be within milliseconds, so this is a very rare edge case. But, think about these things. Okay, so if we're grounded and if input action is action just pressed, so we're pressing down and we're grounded. No, we do want that different. We do want that separate. If you're grounded, we set jump button to 0, and then if you've pressed jump, we want a boolean that is can fall through platforms. Now, the question here is how long do we want to fall through platforms? Do we want to fall through platforms until we are no longer hitting a platform? Do we want to fall through platforms for a certain time? Here is the question. This is how we implement this. Is quite will cause not issues. It will cause certain things to be true. So if we just do it as a very simple time, like 250 milliseconds, it will mean it doesn't matter how thick the platform is. Oh, sorry, it will say a certain thickness of platform, you will fall through it and then pop to the top of it again. Which means you'll have to design your game to always have thin platforms. Make sure that all of your thick, solid things are solid on the solid layer. If we make it so that when we're in the can fall through platform state, we detect if we are colliding with if our down arrow is colliding with a platform, then we do not uncheck it until we are no longer colliding with a platform. Which I think is a better way of doing things. It's a way that I've not done before, so we're going to try it out. So if we can't fall through platforms, and you've pressed the jump button, we'll set can't fall through platforms equal to true. Now, on the test down, we're going to do this. But we're now no longer testing platforms. We now need another collision mask called platforms only. It's literally only what counts as a platform. So if can fall through platforms and not try cast ray put a 0 times horizontal size. So we're doing another raycast whenever we're falling through platforms. Now we have a budget, and we are so nowhere near that budget that this is fine. Raycasts are expensive. We don't want to be doing too many of them per frame. But so long as we keep these controlled, this little extra raycast shouldn't cause us any issues. But understand that there is another way of doing this without the raycast, and that's just having a timer. I'm going to see if this works. So first off, that was a mistake. I need to set the... Platforms only, we'll just have platforms. But this, we do it this way so that we can then set, say later on we might have moving platforms as its own layer. It means we can put moving platforms on both of these and take solid off. And rather than anding these all the time, which is extra processing, we take the hit on these. It gives us a bit more flexibility. There we go. We can now fall through platforms. Now, it's a little bit... It doesn't feel right. It doesn't quite feel right. I mean, okay, you're getting that pop at the top, but... we need a bit of speed when we drop down there. What's our jump speed? You know, we'll probably just put this about 200. So what we're going to do is, when we do this, we can fall through platforms. We're going to set Y speed equal to drop down speed. What this means is, when we do the drop down, we will literally force ourselves down. That's a bit better. A bit more instant. So that's us got falling through platforms. I'm still annoyed that the gizmos aren't drawing properly. Still don't know why that is. It was working before. don't know what that is. Anyway. What can we do next? We could do Coyote jumping next. We could do variable jump height. I think we'll do variable jump height because that'll be an interesting thing to do. The way I used to do it in Unity was using coroutines. I want to look up to see if Godot has coroutines in some way. So I can still use enumerators. I just need to manually iterate through them. Okay, so here's how this will work. When you press the jump button, it will create this iterator. And what will happen is this iterator will go, every time I am called, I will set the jump speed to jump force until a time has passed. Or until a certain time has passed. And then I will end myself. So we need to do that. So that's a basic enumerator. You yield, you return. You yield, you return. You do something, and then you return a pause. So what we're going to do is set y speed equal to minus jump force. And then so we'll do this for 30 frames. We're not. This is the weird part. Is that I'm not sure how I can get delta in here. Yeah, I'm sure there are repositories that replicate coroutine behavior, but I'm not going to go out of my way. I want to do this as bare bones as possible. Also, welcome to the chat. Welcome to the channel. So my only worry here is that I can't get... Can we get delta time in here? No, we can't get... So we'll have to somehow store the delta and pass it into this iterator. Or hold the timer separately? I don't know. So what we're going to do is when... Rather than doing this, we are going to do this. We're also going to have a variable with jump controller. Blah, 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 blah. We could see this null terminating, the null coalescing thing. I have been trained off of using it because of the way Unity handles null, and I don't know how Godot handles it. So we'll try this. It is just a Poco though, so it should just be fine. It's just a plain object. There's no... It's not a Godot object, or in the case of Unity, it's not a Unity object. So I can use an I can use this. I can use this. Yeah, I think this will be better because I only want it to. So this gives me a bit more finer control in the way that Unity's coroutines would work, because Unity's coroutines would work entirely before the physics process would work. Whereas here I can set it to move next during this. So yeah, this should be fine. So what this does is it applies gravity, asks if there's a jump controller. The jump controller will then reset the speed to the jump force. So we should get a higher jump out of this. We should get a variable jump out of this. Yeah. There's a few things we also want to do. There we go. We've got a better jump height, and if I let go early, nothing happens because I'm not testing for that. But we have got a higher jump height, which means it is doing the iterator, it is doing the jump force. So what we also want to do here is, rather than do stop coroutine, because what we would normally do is when we hit our head off, we bonk our head off the roof. We also want to turn off the jump controller when we bump our head. And when else do we want to cancel the jump controller? When you have released the jump button. So we also want to test in here if the jump button is... We want to break early. Actually, no, we just want to break. Because we just want to break out of that loop. So we still get to the end and empty it. Actually, yeah, that's probably a better idea, is... If not... What? Oh, it's because it's nullable. Yeah, if it explicitly equals false, then we set it to null. Because we don't want to be setting a null to a null every frame. It's one of the only reasons, one of the only times we do that, because we can't just not that, because it's a nullable bool. C# thing. We can now yield break, just exit out of this entirely. If we've stopped jumping. What we can also do is if you release it early, we can have a different final jump speed. So something like Sonic the Hedgehog, if you press the jump button, you head up, and you head up for 8 pixels per frame, something like that. And then if you release it early, it slows you down. I think it goes to 4. It halves your jump speed. If you release early, you don't continue up. You just sort of bonk. So we can set that to 0. So something like I want to be the guy has digital controls. If you release early, you go dunk. So you can do an I want to be the guy style triangle jumps quite easily with this. So we'll see how that works when we run it. So if I jump, bonk my head. If I release early, I basically stop myself. .30 frames may be too long for a sustained jump, but we don't want it to be frames anyway. Now I know we basically have a fixed delta, but I don't like assuming anything. Can't pass anything into the iterator. And this feels dirty. So for float equals 0, float t equals 0, t is less than what, b plus equals last delta. That double. So we want this to last for a certain amount of milliseconds. Jump, sustain, milliseconds. We'll set it to 250 milliseconds. So that's jump, sustain, milliseconds. Actually, you know what? Screw it. We don't need that. We can have this entirely within this. What does that actually return? That is a U-long. Okay, so current time minus the start time. Does that actually need that? It does need that. Right? Yeah, so current text minus the start text is less than the jump sustain. It will keep looping around that until it's done. So we don't need the delta. We don't care about the delta. We just care about the number of ticks, which should be how the delta's getting calculated anyway. There we go. We do want to fiddle about with that release, because our jump force is 500. We're now dropping that down by half, and it feels really weird. Yeah, that's a bit better. There we go. So we've got a bunch of cool features that are built into a lot of platformers, a lot of classic platformers. We've got our sustainable jumps, our variable jump heights. We've got variable release speeds. We've got jump buffering, which is incredibly important for precision platforming. You want that kind of easy feel. You want to be able to anticipate what's going to happen, and you want it to feel good. So you don't want it to feel like it's eating your input. That's one of the things that jump buffering does. The other half of that, the flip side of that is Coyote jumping, and we'll put that in a second. We'll go drop down through platforms. That's fine. Gravity. We've got a maximum Y speed. We've got different types of collisions. All of that done. How long have we been streaming for? About 2 hours now? Maybe 3, 2.5? All of that done with a really odd bug in the middle. An itchy ear. All of that done in the middle. So the last thing we'll do is we'll add in our lovely Coyote jumping. Now, what is Coyote jumping? Well, if you've ever watched the old Roadrunner cartoons with Wile E. Coyote, entirely where the name comes from is that cartoon Coyote runs off a cliff and he's just floating in midair. It's only until he looks down that he starts falling. In a similar kind of vein, we want that kind of action for platforms, especially a platformer like this, where we only have one vertical ray. Now, some other platformers have 2 vertical rays, one for each foot, and with that, you tend not to need the Coyote jumping as much, especially if you've got a wide character such as this. So what will happen is, if we were here, our ray would go straight down, hit that platform, we would be grounded. Absolutely fine. We could jump off that. We go to the edge here, our ray would go down, it would hit the platform, it would be perfectly fine. We go here, our ray would cast down, it would not hit the platform, not good. Because we are almost entirely, half of us is almost still entirely over a platform. Then graphically, one of our legs is there. But we would start falling straight away here. Now, with a wide character like this, you would really want to have two down ray casts and 2 up ray casts for your head, just to make your character feel a bit more solid. But we're not going to do that for this engine. What we're going to do instead is going to add Coyote jumping in. Now, what Coyote jumping in... Now, speak words. What Coyote jumping is, in this case, is that for a small amount of frames, once you leave ground, you can still jump. So if we left this here, 1 frame, 2 frame, 3 frames, 4 frames, 5 frames, and we'd be down here a little bit, you could still jump. You could do this and then jump again. But once you get past this threshold, once you get past the speed, the time, the delay, you wouldn't be able to jump. So it's like this sort of reaction thing again. We've got to think about what the best time to react to that is. What a human's average reaction speed, again, is about 250 milliseconds, 200 milliseconds. For Coyote jumping, again, it's an anticipated one. It's not an actual reaction. So we can reduce that time, again, to about 10 frames, maybe less, depending on how relaxed you want it to be, depending on how precise you want your jumping to be. There are some platforms out there with like 2 or 3 frame windows for your Coyote jumping. Others out there with longer ones. We're going to make it variable so that we can decide later on what our Coyote jumping time is going to be. So, back into the code. We're going to add a variable called Coyote jump, milliseconds. Also, all these ones with times, I'm putting milliseconds on the end of the name just so that we know that they're a time. And we're going to put that to, again, 170 milliseconds, just like the jump buffer. Again, that's about 10 frames at 60 frames per second. Slightly more, just so that if the deltas don't fall in the right place, it still counts. So, how do we do that? Well, this is grounded is going to have to change. We're going to have to do a can jump. So you can jump if you're grounded. That's fine. We know that's true. What we're also going to add in here is, when was the last time you were grounded? So we're going to add in here private double the time you last lost ground. Now, how are we going to do that? We're setting ground to null in a bunch of places. Like, what is this? This is all over the place. So what we're going to do is we're going to consolidate that into a function. We're going to do transition to air, transition to ground. If current ground is null, return last ground at time, get ticks millisecond. We're just bombing out if we call this prematurely. It means that what we can do is just do this. So if you don't hit anything on the ground, you transition to air. Easy. Now we put all this stuff in here. Now transition to ground. We don't really need this in this platforming engine. But we will put is really the only time we're going to call this function. Make that 2D node. But if we were to do more complex stuff, such as moving platforms, stuff like that, we might want to call transition to ground in other places, but generally we don't. We might want to do some weird stuff, like if we're doing momentum-based stuff. Like if you're in the air and you're moving to the left, we might want to have it so that you transition to ground, and if the ground is at a slope, it gives you a different speed, like it speeds you up or it slows you down, depending on the angle of the slopes. But we're not going to do that for this one, but it's just there, just for consistency, and just so that we can use it and not have to think about it. So transition to air, we need to go and find all of our references to current ground. And all the times we set current ground to null. Okay, I'm going to transition to air. I'm going to put that first. That's our transition to air. And, oh, we've got the generated script stuff into here. Just ignore that. So I think that's the only two places we will be calling transition to air. Now, what we can actually do here is we can just do that. So we'll do it at the start of the whole jump. Rather than doing it in this, we're really just calling this. So where were we? We can now transition to air anywhere we want. And we know when we lost the ground at. Let's go back up to can jump. Where is that? There it is. So if can't jump, so this we'll pare this down a little bit in a second. But I just want to get the logic out there. So you can always jump if you're grounded. That is always true. If you can't jump, as in if you're not grounded, and you're within the Coyote jump time, then you can jump. So let's see if this works. First and foremost, before we boil it down a bit. We could... I screwed something up. I've screwed something up. Let's take that out and just make sure that this still works. I might have screwed something up with the is grounded. Yeah, I've messed something up with the is grounded. We transition to ground. Current ground is that. Transition to air. Current ground is current ground. Oh, I know what it is. It's not doing the first version of the iterator. Yeah, so I do need to put transition to air in here, I think. Yeah, that's what it was. Yeah. It doesn't do the first iteration until you call move next. That's my own fault. I'm still... Iterators are a pain in the arse. I much prefer using async. I'm much more comfortable using async awaits. in my C# than using iterators just now. So yeah, our can jump, we can put that back in and test it. This will be the last thing we do. I need to go and get some lunch. So you can jump. You saw there, just as it went off, we can still jump. We'll make that a bit more obvious, again, by making it a ludicrous. So where are we? Jump force sustain, jump force release. Where's the Coyote? Did I export? I didn't export Coyote. Okay. That's my own fault. Yep. We do a build. There's Coyote jumping. We'll put it up to full second. So now, there we go. Falling off the platform, we can still jump. Make it slightly. We'll make it 300 milliseconds so you can. That should still be enough to see it without. Actually, no. We will move the platform up. So that we can see it properly. So you can see there, I don't jump until I hit the ground there, but I can jump right there. I don't jump if I've gone too far down. But I do jump if I've just gone there. That's Coyote jumping. And that's how easy it is to implement. And all these games, all these platformers that don't have it, really annoyed. And I'm also incredibly annoyed it's because it's very simple. Jump buffering and Coyote jumping, very simple to implement. Does kind of complicate things, but we can make this a lot simpler. So what we can do is you can put that as an OR. Just make sure that that looks a bit better. So if you are grounded, you can jump. If you're not grounded, it will check the difference and that. Which means that when you're in the air, this will always be called. This will be tick, 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 ticking all the time. It's not great. But again, I don't know the impact of this, but I'm assuming we have 12 into this. I'm going to do a search for this just to see if I can find the source code for it. It shouldn't be too processor intensive. It's going to be the way I would assume that this is working is that it's just a function call that's going off to a stored variable somewhere. It's not going off and calculating anything. So it should be fairly quick to just grab that. The same with the input system. Every frame the input system updates and all these functions are doing is referencing a table somewhere. Really give us much. Let's see if we can't find the source code for Godot engine. There we go. On GitHub. Let's see if we can't find the time. Oh, I'm not signed in. Oh, for fuck's sake. It won't let me search through the code without signing in. Fine. Right, here we go. We're just going to assume that it's fine. We're just going to assume that it's fine. It's not going to cause us any issues doing this every frame. Because there are a few things. So from Unity, so this is where I've learned to care about how some engines do things. From Unity, it used to be that all the tutorials would do something like get component. Like every time it wanted a component, it would get the component and it wouldn't cache it anywhere. You'd have to do the caching manually. Or broadcast message, things like that. Broadcast message is an incredibly expensive operation in Unity, but it's something that's encouraged to be doing all the time. So I've always been wary about engine-based actions like is action pressed and get text milliseconds and stuff like that. Stuff that you don't instantly think might cause a problem if you're calling them every frame, but might actually have some nasty stuff behind the scenes that the engine